let me review what we did last time. Correct?
Yeah.
Now, periodic function is anything that repeats in time. Yeah. So the thing will keep on repeating in time. So, like suppose if you have a Ferris wheel which is there, it will go round and round and round.
Right.
So this is what we started with the Ferris wheel.
Mm-hmm.
Correct? So it says that create a sketch of the height of passenger car on the original Ferris wheel as the car rotates around wheel 4 times.
Yeah.
So as the sketch, a sketch of height versus number of rotations. So you have height versus number of rotations. Right. Assume that a car starts at the very bottom. So car starts from the very bottom, obviously because you'll hop in the car from the bottom only.
Yeah.
Correct? And assume that your car starts at the bottom.
Mm-hmm.
The height of the Ferris wheel was given to be 260 meters over here, 260 feet tall, tall. And rotates once every 9 minutes.
Right.
Means one rotation takes place 9 minutes.
Right.
So that means if you're at the bottom, you sit in this, it will go round and come back at the bottom in 9 minutes.
Right. And that's why you consider it as one.
Yeah, one that's a one period. One rotation is 9 minutes.
What if you put 9, 8?
Yeah. So then instead of number of rotations, you have to put time.
Time, okay.
So because they're asking you the number of rotations over here,
right.
Sketch of the height versus the number of rotations.
So then you just draw forward.
So then rotations I can call 1, 2, 3, 5. I can call it 9, 18.
Right.
So if they say time, then you do that.
Yeah.
So you start from here, go to maximum, then it comes down. So that's your one rotation. This is your second rotation. Correct? And this is your third rotation. And this is your fourth rotation.
And the line through the middle of 130.
Because they've asked to put 130 in the middle.
Right. Okay.
So they'll put that. That will become your principal axis.
Right.
The amplitude will be from here to here. 130.
Okay.
From midline. So this is the midline. So from the midline to the extreme is the amplitude.
So 130 to 260.
Or from 130 to 0. That's also the amplitude.
Okay.
It should be equal. It will be,
What does the amplitude do? Is just
nothing. Okay. This will be using that.
Okay.
We'll be using that to make the model.
Okay.
Now here they are saying you take a paper plate, mount it as a Ferris wheel and move it around. Every 15 degrees. And for every 15 degrees you measure the height from the ground.
This is what I was a little confused about.
You did this?
I did this, yes.
Where's that?
And everyone so this is how I
No, you have to actually do it.
Yeah, no, I actually measured these lines.
Oh, okay, you actually measured
it.
Actual,
centimeters with a ruler, right?
Correct.
So is this how I'm supposed to do it? Like, did I do it correctly? Because I didn't ask to show you off or anything.
Yeah, correct. You measured this.
I measured this.
Then you measure this.
Yeah.
Then you measure this.
Yeah.
Then you measure this. Then you measure this. Measure this. Yes.
Yeah. But the only thing I didn't get is, so this is 0 degrees.
Experiment, you'll get a graph like this.
Yeah.
So basically you're starting from let's say 16 meters.
Right.
Then you'll go to max.
Right.
You'll go on top. Then after that you'll start coming down. The point comes, the height keeps on decreasing.
Right.
It comes back to that normal, the midline.
Yeah.
And then it goes back to 0 and then it comes up again. So that's how the rotation is happening.
That's all this.
So that's how this point over here starts from here. It goes on top, it becomes max. Then at the point starts coming down.
Yeah.
Then it comes at the same level as where originally it was.
Yeah.
And then it keeps on going down, becomes 0.
Yeah.
And then again it rises.
Okay.
So you're looking at the height of this point from the ground, point P.
Point P, yes.
So imagine you're sitting in a Ferris wheel and you are seeing your height. You experience your height. So what do you think? What's happening to the height from the ground?
Right.
So you're looking at the ground continuously.
You keep on going up and then you go back down.
So you imagine that.
Again. Okay.
So that's how you look at it.
Right. So then here's when you go, okay, yeah, makes sense.
Here this is your topmost point.
You're at the top point, then you go to the
Then obviously once you reach the top point, then you have to come down.
Yeah.
Because the Ferris wheel will start, that car will start coming
down.
down.
Come down and go up again.
If you're sitting in the Ferris wheel, imagine you're sitting in the circle. Here you are. You started here.
Because then it goes
You'll
back
go up,
here. That's where.
Then you're back here.
That's where 0 is.
And why. Then you go down.
Right.
And then you start going up.
Yes.
Because you're starting from here.
Right.
Now in this summit was starting from the base.
Right. That's why. But now we're starting from here.
That's starting from the midpoint. This is starting from the midpoint. So you have to be careful where it starts from.
Right.
Otherwise,
Otherwise I'll mess up
your interpretation will be different.
Exactly. Yeah.
And you think whether it's going up or going down.
My interpretation was actually very different. Yeah.
So how would your graph for exploratory challenge 2 change if the diameter of the wheel was double? So if the diameter of the wheel was doubled,
diameter affects the radius, right?
Yeah, radius. So when you double the diameter, radius will also double.
Right.
So that means you will reach double the height.
Right. So then the range.
So the amplitude will increase. The height of the graph
height,
will the amplitude.
the range.
The whole range will increase.
Yeah.
So height of the graph will increase and hence the amplitude will double. The range will double.
The range will double. Okay.
If you translated the sketch of the graph down by a radius of the wheel, what would the x-axis represent in this situation? So if you translate this graph, if you translate this graph down,
right,
like this,
right, then that won't work though, because then the Ferris will be going underneath the ground.
So that means, but you're taking your reference level to be from here. You're taking your zero line to be here. You're not taking the height from the ground.
Yeah.
You're taking the height from this midline.
And then you're moving it down.
Yeah, so then you're moving it positive, and then when it comes down, it will be negative.
Right.
It's going below the reference line.
But it can be negative.
It can be negative. When it's going below the reference line, then you start.
Right. Okay.
Are you following?
But in this certain situation of a Ferris wheel, it can go negative, can it?
Yeah, it can be negative.
Can these graphs go negative?
Yeah, the height can be negative.
The height can be negative?
Means it's going below the level.
Can a sine function have negative values?
Function can have negative.
Function, and do you have to translate them?
No, they'll ask you. Follow the instructions.
Okay.
Amplitude is a displacement from the mean position.
Right.
That's
the middle line.
Yeah.
In between the highest point and the lowest point. Right?
In between the highest point and lowest point. Now, a small pebble is lodged in the thread of a tire of radius 25 centimeters.
Right.
Sketch the height of the pebble above the ground as the tire rotates counterclockwise, anti-clockwise. Correct? So here this is going anti-clockwise. So it starts from here.
Because at 9 o'clock.
Start the pebble is at 9 o'clock position.
Right,
so this is a 9 o'clock position. So what will happen first?
So then it would move
up. It will move up.
Yeah.
Then it will move down.
Move down. Then it will move up.
Then it will become, the height will become 0.
Yeah.
Then again it will become 25.
Yeah.
So this moves up, moves down, comes here. That.
And since the radius is 25, the diameter is 50.
Correct.
So that means that the maximum point is 50.
50.
You just know that.
You're 50, yeah. Okay. You're 50 meters above the ground. Okay. And this is 1, this is 2, this is 3, and this is 4, 5.
So 5 turns, yeah.
5 turns. Now, the graph that you created from 2 represents a function. Describe how the function and the graph would change if the tire radius was 24 inches instead of 25 centimeters.
The maximum point would change and it would become 24, 48.
24 and 48.
Yeah.
Correct. Describe how the function and the graph would change if the wheel was turning in the opposite direction. Instead of going counterclockwise, suppose it was going clockwise.
The graph would be opposite way.
Yeah, opposite way. Means instead of going up, it will start going down. So this is the graph.
Yeah.
So it will start from here. It will go down. It will go here, go up,
right,
and go down, and this way it will go.
Right.
Describe how the function and the graph would change if we started the graph and the pebble was at ground level. So you think of the height. The height of the pebble will first be 0.
0. And then it will go up.
Yeah, it will go up in this way.
Yeah. Same. Wait. If this is starting
from the ground level.
No, because now these are at the ground level. But this one's, because it's saying here at the 9 o'clock position, right?
No, but now they're saying 9 o'clock.
Now it's saying
ground level.
Right,
so you don't look at this.
Right, okay.
I'm doing 2 C, I'm not doing 1 A.
Yeah. They're not even combined.
Yeah.
Sorry, man.
Basically, this is the height. This is the height. This is called the co-height.
Yeah.
So height is the distance from the x-axis, and the co-height is the distance from the y-axis.
Right.
Each of the point P1 to P8, P3, P4, P5, P6, P6, P7, P8 on the diagram on the right represent the passenger car on the Ferris wheel. Those segments that represent the co-height of each car.
Okay,
so
I think I know how this works.
So co-height from each would be?
Yeah.
This would be the co-height.
Right. That would be the co-height. Yeah. Exactly. So first would be P5 because the left side is negative, right?
Yeah.
Like smallest.
Correct?
Oh, it's just asking which cars have negative.
So which car has positive co-heights?
Oh, okay, so.
Draw segments, okay. Which cars have positive co-heights?
Should we first do negative?
No,
Okay.
positive. Are they asking positive?
P2, P3.
P2, P1.
Is that P1, P5?
P8.
Sorry, I can't see.
P8.
P8, P7.
P7 have positive co-heights.
Yeah. And then.
Correct, these are positive co-heights.
Yeah,
negative co-heights.
P3.
P3.
P4.
P4.
Is that P5? Yeah.
Yes, P5 it is
P6.
P5 and P6. List the order of increasing co-height.
Okay.
List the smallest co-height first.
So the smallest would be the biggest on the left side. So P5.
Correct. P5.
P4.
P4.
P3.
P3.
P6.
Yeah.
P2.
Yeah.
P7.
Yes.
P5. P8.
P8 that is.
Sorry, P8. I don't know why.
No, P1.
Sorry, P1.
P1 and then P8.
P8. It's blurry, right?
Yeah, it is blurry.
It's not my vision. I hope my vision.
No, it's blurry because he has copied pasted this image from somewhere.
Right, yeah.
Okay?
Yeah.
Fine.
Okay,
Suppose
that the radius of Ferris wheel is 100 feet.
So see, so always, you know what I'll tell you, always draw a diagram. So radius of the Ferris wheel is 100 feet. So radius is 100 feet. So you know this means, and rotates counterclockwise. It rotates counterclockwise.
Right.
Correct? Define a function that measures the co-height of the passenger car as a function of degree of rotation from the initial 3 o'clock position. So let's do that. So you start with the 3 o'clock position. It's going anti-clockwise. So see, if you're looking at the co-height.
Yeah.
So first my co-height will be maximum.
Right.
So if I'm drawing my graph.
First you'd start at 3 o'clock. Right.
So 3 o'clock means is maximum.
Maximum, yeah.
Then this is maximum. Maximum.
1/200.
Correct. So that is how much? 100.
Oh.
Radius is 100, no?
Oh yeah, right. That's not the maximum though, right?
100, no? This is 100, no? Maximum, no?
Oh, okay.
This is maximum.
Okay, yeah.
100. Now suppose it goes here. It will be less than 100.
Right.
Then when it goes here, what will it become? 0.
0, yeah.
The co-height will be, you're looking at from the dotted line. You look at the distance from
Yes.
You're looking at the co-height.
Yes, okay.
So it becomes 0 over there.
0, yeah.
Then here it will become negative.
Negative, yeah.
The negative.
Here it becomes negative, yeah. And then here it becomes 0 again. Like on the
correct.
Part,
so 0 again.
It goes up. Okay.
Correct. So let me label this as. So this is your, let's say this is your point A, this is your point B, this is your point C, this is your point B.
Right.
Correct? So A corresponds to A, this is B, this is C,
okay,
and this is D0, correct?
Yeah.
And E is back to here.
Right. That's a nice way to visualize.
That's yeah. So that you know which point corresponds to what.
I can look at this now.
Yeah. So therefore we are doing this so that you can see it.
This is very smart actually.
Yeah. Correct?
Yep.
What is the domain of the co-height of the function?
The domain. So would it be -100, wait, no, the domain.
One turn. It's going through one turn only. They're saying that it goes through one turn. So domain for one turn will be what?
It would be -100,
0 to 360.
Because 360
one turn,
degrees. No? Oh, and the range would be -100.
So 0 to 2 pi if you're looking at radians.
Yeah.
Correct? Degrees if you're looking at this.
Yeah, I haven't learned this properly.
Acha, radians you haven't.
Radians I haven't learned.
Acha, so you can say 0 to 360 degrees.
Yeah.
360 degrees is 2 pi radians.
Yeah. I think because maybe they did it in math too. I just never.
Okay, radians is just a different unit.
Yeah, okay.
Like inches and centimeters.
Right.
It's a unit.
It's whatever you want.
So 360 degrees is 2 pi radians.
Right.
There's nothing to know in that.
Okay.
I mean nothing. It's just there. It's
there.
just a relation.
Right.
Yeah, it's just there.
Okay.
What is the range of the cofunction?
This would be -100, 100. Because
Correct.
it goes down.
Correct.
Okay.
Because this side is negative, no?
Yeah. I was getting confused with the range and domain.
Correct?
Yeah.
Now, how does changing the wheel radius affect the domain and range of the co-height function? So will the domain change?
No.
No. Domain remains unchanged.
And if you change the
And what happens to the range?
the range would decrease.
Range, if you...
Oh, if you change it,
So
the wheels in a positive,
range will change, no?
range will change.
Range will change. If the range will change.
Yeah.
If the radius increases, range will increase.
Yeah.
And if the radius decreases,
Then it decreases.
range will decrease.
Right.
Okay, now next question. For a Ferris wheel of radius 100 feet, so again, you have a Ferris wheel. The radius of this is 100 feet. Correct? Going through one turn. So it's going through one turn. How does the domain and range of the height of the function compare height of the function compared to the domain and range of the height of the co-function?
Right. So when you're looking at height, you look from the ground level.
Yeah. So now if you're looking at the height, where are you starting from?
In this case, you're starting.
They are not mentioned. So suppose where you want to start from, you decide where you want to start from.
You can start from here.
Ground, okay.
Ground.
So you decide to start from here.
Yeah.
So what is the height?
The height is 0.
0. Then at B, what's the height?
The height is 100.
100. Correct?
Yeah.
At C, what is the height?
Would it be 200?
200.
Yeah.
So basically, you know, it's going.
Yeah,
like
I'm
there.
getting the hang of it now. And then it goes back down. Here it goes back down. Right?
Correct. So you're starting from 0, and this is 100 feet. Correct?
Yeah.
And this is your one rotation. That's your 360 degrees. That's your one rotation.
Yeah. Wait,
Correct?
one thing.
Huh.
So here it's at 0. Okay. Here it goes to 100. Correct?
Yeah, it goes to 100.
100. Then here it
goes
goes
to
back to 0.
200.
Oh, 200. But you
Height, no height. You're looking at the height from the
Oh,
ground.
right. This is co-height.
You're looking at the height from the ground.
The ground. Okay.
It's what you did in that sum.
Right,
You're looking at the height from the ground.
Yes.
So your D, so this is your A.
And then it goes
That's
back to 100.
That's your B. That's your C. C is the topmost height. That's your D, and that's your E.
Okay. And you're not putting 200 here?
Yeah, 200. Sorry, this is 200.
Okay. That's what I was confused about.
Right.
That's
This
why
is this is 200. Yeah.
Okay. Now
That's
everything makes
200.
sense. Yeah, now everything makes sense.
Now co-height. So let's
Okay.
look at the co-height. So co-height is what?
The Y, the length of the Y.
So if you're looking from this, you draw a line here.
Yeah.
And
And then you
you're
label
starting
the
from
point.
bottom, no?
Yeah.
You're starting from here. Then you'll take this.
Yeah.
Correct? Then you'll take this. Then you'll take this.
So
Even if you take 4 points.
Yeah. So how would you take this? You just
So
look at
see,
the
so suppose A, B, C, D.
right.
Acha, you look at the distances from this line. So what's the distance? 0.
0.
Correct?
Right. And
Then you
draw
look at this
that
distance. That's 100.
line. 100. Yeah.
So let's say 100. Correct? This distance is 100.
Okay.
Then here the distance will be less. Suppose if you have some point here.
Yeah.
So that distance will be less. Correct?
Hmm.
Here what will the distance be from the red line?
200. No, 0. Sorry.
0. So you're back to 0.
Because it's on the line, right?
Correct. Here
It would be 10, 100,
minus 100
minus 100, yeah.
because it's on the left.
Right. And then it go back to 0. Okay, cool. That makes sense.
That's your co-height.
Yeah, makes sense now.
Co-height with one revolution.
Yeah.
So this is your A when it is 0. When it's on that line.
Yeah.
B is the maximum distance from this line. Correct? C is again back to 0.
Right.
Okay, and your D is this. D is your maximum on the left hand side.
Right.
And E is back to 0 here. E means this is back, you're coming back over here.
Okay, I like the way you're labeling this.
Yeah. So now what's going to happen? So what's your, acha, so now let's write the domain and the range. So what is the domain for the first one?
Okay, so if it's just one turn, so 0, 360.
If it's just one turn, 0, 360.
If it was 2 turns, would it be
0 to 270.
270. Okay.
720.
720.
Range?
And the range would be minus
Range for the height.
the height. Okay, 0, 200. Sorry, my mistake.
Okay. Now for the second one.
Yeah.
Domain?
So the domain would be 0,
0 to?
360.
Yeah.
The same thing. And this would be minus 100, comma 100, right? Okay. I get it now, yeah.
Correct?
Yeah.
Will it be true for anything? Yes. If the starting point is the same, it is the same.
Right. Yeah.
It can't change. No? Only the amplitude will change.
Right.
If the radius is more, that 100 will change.
The 100 will change.
Everything else will.
Yeah.
Now, the Seatle Great Wheel has an overall height of 175 feet. So overall height is 175 feet.
Right.
So the diameter is 175 feet, basically. Correct?
Mm-hmm.
Was the tallest Ferris wheel in West Coast at the time of construction? 2012. For this exercise, we'll assume that the diameter of the wheel is 175 feet. Create a diagram which shows the position of a passenger car on the great wheel as it rotates counterclockwise. Counterclockwise means it's going how?
Mm-hmm. Like that. Yeah. Like
Counterclockwise at 45 degrees intervals. So at 45 degrees intervals. So let's draw this.
Okay, so
this is 45.
45, 90.
90 plus 45, 135.
135.
135 plus 45,
180.
180. That's a one cycle. 360 is one cycle.
Yeah.
So then 180 plus 45 is
225.
225. 270.
270.
Correct. Then 350.
Yeah.
Correct.
Yeah. And then 360.
7 and 360.
Yeah.
Yeah.
Okay.
Now you think of the height.
175 is the max.
Max is 175. Yeah.
Yeah.
So max is 175. Now imagine that you're boarding from down, obviously. You're boarding from down.
Right.
So will the height increase or decrease? So 45 degrees.
When you are from 45 degrees, it doesn't say where you start. Okay.
You
start from the ground. Yeah.
Yeah,
Okay.
you start, I mean, you always start from the ground.
Right. Yeah. Okay.
I mean, so then this is going like this.
Yeah.
So 45 degrees will be here.
Mm-hmm.
90 degrees would be here.
Right.
This would be your 135.
Right.
Correct? This
And
is
then-
your 90. This is your 135 degrees.
And the top would be 180.
180. Correct? Then this would be 225.
225.
Then this
that
is
would be 270.
270. Correct?
Yeah.
315.
Yeah.
Correct?
And then 360.
360 is back here.
Right.
You understand? Now you
Yeah.
think of the height. So when it is so basically
so at 90.
so see you think like this. You think like this.
Yeah. Okay.
So this is the height. This is zero height. And the maximum height is how much? 175.
Right.
And the midway will be how much? What is half of 175?
80.
8 to 8 that's it 2 7 87.5.
87.5. Yeah.
So when it's 90 it's
So, yeah,
midway.
it'd be
Acha,
halfway.
so it starts from 1 second.
Yeah.
Let's start stepwise.
Okay.
So 0 is 0.
Yeah.
45 is somewhere here.
Yeah.
Correct?
You just
90 is midway.
90 is midway.
Correct?
135.
So 180 is maximum.
Right.
Correct?
Mm-hmm.
Then 270 is back to midway.
Yeah.
360 is
0.
so that means
You just draw it like that. Because you get the idea.
You just get the idea.
All you need is 3 points realistically.
3
right?
4 points here.
Yeah.
Just think where's the max, where's the min.
Right.
Bas.
Very nice.
And this is one rotation and then it continues. Correct?
Yeah. On the same set of axes.
On the same set of axes, sketch a graph of the height and the co-height of the passenger starting at 3 o'clock position. Now this was A. Now day A we started from the bottom. We didn't know. Because that the instruction was given for here.
Yeah.
For part B. So for part B, if you look at, so let's see now.
Now they're starting at the 3 o'clock position.
1 second. What will you do is, first we'll draw a circle.
Yeah.
Mark the angles on the circle. Correct?
Right.
You're starting from 3 o'clock.
Yeah.
So t is equal to 0 means you start from here.
Yeah.
So that's your 0.
Yes.
This is how much? What degree?
This would be 90.
Yeah, obviously.
Yeah, 90.
This
would be 270.
Arey, how?
Oh, sorry.
See, imagine you draw this. This is 0.
0.
Imagine this is opening up.
So it'd be
90, 180.
180, yeah.
Arey, 90 and 90, no? This is.
Right. Yes.
Then 9 3s are 27, 270.
270.
360.
360. It was just weird to visualize because of the
So, yeah. So 0 degrees, 45 degrees, 90 degrees, correct? 135. We won't do this 135 now. We'll just draw, they want only the variation. Na?
Yeah.
90, 180, 270, 360.
Right.
Correct? Now let's look at the height. Height, if you look at 0 degrees, what's the height?
It's 0 degrees, it's half.
What's the height from the ground? 87.5?
87.5, yes.
175, so 87.5. At 90 degrees, what's the height?
Maximum. So 175, yes.
180?
The same as 0.
270?
270 would be negative.
What's the height from the ground? Rohan, you can't.
0. And this
360, what's the height from the ground?
87.5.
Imagine you're looking down.
Right. 87.5.
Imagine you're looking down.
Yeah.
Now when you're looking at the co-height, no? Are you following that? So
Yeah.
here you look down.
Yeah.
Here now, what you do is,
You look from the
you look at the blue
The
line.
line,
You
yeah.
look how far
From
you're
the
from this
line.
blue line.
yeah.
Okay. So when you're 0 degrees, what's your co-height?
At 0 degrees, halfway.
So what is it? 87.
87.5.
And 90 degrees.
90 degrees, you're 0.
Correct. You're on the blue line.
Yeah.
Okay.
180, you're also 87.5.
But you're on the left.
So minus 87.5.
You're on the left.
Right.
Correct.
And then 270, you're also 0.
Yeah.
And then at 360, you're 87.5. Okay, yeah, now I fully understand this, yes.
So imagine where you're looking. So if you're looking at the co-height, you look at the blue line. If you're looking at the height, you look at the black line.
If you're looking for the height, then you just
Look
look
from-
down.
look down.
Look down, okay. and
Co-height, you look at the blue
co-height,
line.
you look at the blue line. I'll remember that. Yeah.
Bus. Just draw that and now you draw the variation. See that? So now let's do the height versus that on the same set of axes they want. Correct?
Right. So
Sketch a graph of height and co-function as a function. One turn, completing one turn. Correct?
Right.
So that's 0, 90,
180,
180,
270,
270, 360. This is a rotation.
Yeah.
Correct? So this is the height as well as the co-height. We'll draw
Right.
both over here. So let's do height in red first. So height first is how much?
87.5. At 0.
So 175 and 87.5. So at 0 it's 87 because you're starting from 3
Right.
o'clock.
90 is the top, 175.
Then
180 is halfway, 87.5. And 0, then 87.5. Okay, yeah, it makes a lot more sense now.
correct? This
Yeah.
is your height graph. Now let's look at the green as co-height.
Yeah.
So
So
0 is
on the
87.5
same, yeah.
and
then
90 is 0.
0 minus
180 is minus
87.5,
87.5. Then 0.
right? And 87.
This is your cosine graph.
Yeah. Cosine?
Cos.
Cos.
This is your co-height. Anyway, that will come later on.
Okay. Okay.
You got the idea?
Yeah,
What
I
to
got
do?
the
You think
idea.
how the height,
Yeah,
how
yeah,
the
yeah.
values are varying with time, with the rotation. Discuss the similarity and differences with the graph of the height function and the graph of the co-height function. So both of them have period of 360.
Yeah.
Correct? The height function resembles a sine graph,
Yeah.
and this co-height will resemble the cos graph.
Cos graph. That's cool. I don't fully understand that yet, but I'm sure I'll.
Yeah, that's
I'll
your
start
sine
to
graph.
get
This
it.
is
Yeah.
So if you do sine of any function, it will look like this, and the
Okay.
cosine will look like, it starts from maximum.
This is what the
Cosine.
graphs are. Okay,
This
I
is what
see.
the graphs are.
Okay.
You have never seen them, but yeah, this is what the graphs
yeah.
are. Acha, you can also say that your height function starts from the midway, goes maximum, and then you can describe in words,
Yeah.
literally what
Yeah.
happens. Consider Ferris wheel, explain how you identify the radius of the wheel from either graph.
The radius halving the diameter.
From the graph. So suppose from the graph, how do you come to know the radius?
The midway.
Yeah. So whatever the maximum height is, half of
It's
it.
half of that, yeah.
And here it's the 0 to that, the amplitude basically.
Yeah.
Amplitude is
In
zero.
between the highest point and the lowest point.
Yeah. Consider Ferris wheel of radius 40 feet is rotating. So see again, what will we do? What did I tell you? Should draw a
Draw a
diagram.
circle. Yeah.
Draw the circle. Draw the circle. First you look at the starting point.
Yeah.
It's rotating counterclockwise.
So that way.
Counterclockwise. Okay, it's going counterclockwise. Okay.
With the radius.
At what amounts of rotation are the values of height and co-height functions equal? Okay. Does the result hold good for different radius? Yeah, it will hold good for different radius.
Yeah.
Now it depends on where you're starting from.
Right.
Where you want to start from? Ground?
Ground.
So you can start from ground.
Okay.
Correct?
Yeah.
So how will my height change? So height is first 0.
For height is first 0.
Maximum. This is how your height will go.
Yeah.
It's very easy to see that.
Yeah. Very easy.
Correct. Now the height will increase, that become maximum, and then it will come back.
Right.
So this is your 0. This is your 360 degrees.
Right.
That's your height. That's how your height changed.
Right.
Co-height. Now co-height will, now you have to take the distance from the blue line.
Yeah.
So what is the first value? 0.
0.
Then
it's the
it's
same.
positive.
Then it gets positive. Then
0.
Then
Then
it gets
become
negative.
negative.
So it's the same.
0, correct?
Yeah.
Then where is it maximum?
Maximum is
At
here.
This is
Wait, no, here.
this is 180. Correct. One second. This is 180.
Yeah.
This is 90. Correct. So where's that maximum at 90?
90. Yeah.
Yeah.
And then it goes down.
Yeah,
Then
yeah.
up. Yeah. And this is the sine. This is cosine.
So where will that be equal?
At 0 and 90.
Correct.
Yeah. Because they're like positive.
Yeah.
It's still
0
going
and
up.
90.
Yeah.
Correct.
Cool. Yeah.
Yuki is a passenger. Is on a passenger car of a Ferris wheel at 3 o'clock position. The wheel rotates 135 degrees and gets stuck. Okay, we'll do this next time.
Okay. But
I
yeah.
need to go somewhere.